Hi, my name is Juan Martinez Moreno. I'm a current student at Tandon School of Engineering at New York University. I'm currently studying or pursuing my master's in cybersecurity. Um, for my topic, I wanted to choose something that fixed the security vulnerability that IoT devices were facing. In this case, I wanted to secure the authentication of baby monitors through an authentication protocol named FIDO. Being said that, today we're going to be discussing some background information on IoT devices, what they are, what vulnerabilities they have, and some common um, vulnerabilities found in some models of baby monitors. So we can jump into the problem and motivation that actually made me write this paper and do the research for it. Um, then the hypothesis and the empirical evidence, what we stated, what I found, what evidence we used, sorry, um, so that way I can show you how we came up with the idea of using FIDO as an authentication protocol. Now the conclusion is what we found after the empirical evidence, and the future work will show what we think it's best to do after um, um, I wrote this paper. So let's jump into some background information. What is IoT? So IoT stands for Internet of Things, and those are devices that normally are characterized by their low cost of production. Um, but the bad thing about that is that that comes with lack of security due to the engineers that created these devices that they don't patch these devices as often, since it requires time, money, and these devices are characterized by what we said that before, which is the low cost of production. Um, Now, some examples include baby monitors, healthcare devices, smartwatches, smart thermostats. Now they came up with smart fridges, smart sprinklers. Sorry. Um, so really, this is something that contains personal information of our everyday life, and being a security um, so being a device that does lack security can affect can put in danger our personal information that is collected by these devices. So sorry. So something to say about baby monitors is that there is three types normally: uh, digital, analog, and analog. Those are two types of baby monitors that use frequencies and signals. um, we're not going to be discussing this, but just some background information on those is that they're hackable as well, since a hacker can actually connect to the same frequency as these baby monitors and can listen to the conversation. But also they can the owners of the baby monitor can listen to the hacker if he or she talks. But we're gonna be focusing on Wi-Fi enabled baby monitors. Those allow distant family members to actually connect together with a newborn baby. So let's say you are in Australia, your baby lives in, or your baby is in Iowa. You can actually see them all the way from Australia, which is pretty impressive. Now, since they're connected to the internet, that's why unethical hackers can like this a lot, because they are vulnerable as any device, since they're low cost of production, and they do this by exploring some common vulnerabilities that we're going to describe in following slides. but some of them are in encrypted storage, remote shell access, backdoor accounts, or UART access. We're going to be focusing on remote shell access and backdoor accounts, but just to know, UART access is a hackers use the actual device, so physically they can hack into it and they can physically access the device. Now, these are some of the common vulnerabilities that are found in baby monitors. Clear text local API, where local communications can be captured by the hacker and they can see them in plain text since they're not encrypted. Clear text cloud API as local communications. They can also capture remote communications since they're not encrypted. Now, in encrypted storage, this is actually important since these baby monitors, let's say they actually save their recordings of the babies or they contain personal information. If a hacker gets a hold of this, they will not need to actually unencrypt anything. Unencrypt anything. It's not encrypted, so that's something that it's a big vulnerability since personal information is stored in these devices. Then remote shell access. This is how they can actually connect to the device through a command line interface and do all kind of things from commands to attacks to extracting information. Now they can also do this backdoor accounts where normally they use this for engineers that created this product use this for trying to test or trying to push any patches that need to be pushed, and they expect the user to change these default passwords, which are really easy, like user can be user password, and they can be found online due to the leaking of these passwords. There was an attack actually that happened called the Mirai botnet attack, where thousands or millions of IoT devices got hacked, and they were used to DDoS a server, and of course it crashed. And then finally the UART access, which they can actually hack the device physically. But now let's actually look at some of the vulnerabilities. So the first column, you see the vulnerability name. This is so this is how it works. CVE stands for common vulnerability and exposures. That first number is the year where they found the vulnerability, and the next number is the ID that identifies that vulnerability. The hacking method can be remote or local, so depending if it can be hacked from far away or you need to be within the network. Next, it will be how you do it. So backdoor credentials will be mentioned, simple as user, and you can log in. Store cross-site scripting, that's through affecting the website that the IoT device offers. And the last column are the models of these devices. So now, what's the problem and motivation here? So the problem is that these IoT devices can be really good for your everyday life, but at the same time they lack something, which is security. And that's really appealing to cyber criminals since they have weak networks or they come with default weak passwords, and that can actually be taken advantage of by hackers. And that's what I wanted to solve. I wanted to see something that first, users didn't have to change passwords. They just have to worry about using their device, and if they want to log into the console, using a passwordless authentication protocol, without having to remember any passwords, even to change any passwords, um, but also to secure the IoT device as well. So that's what motivated me. Now, hypothesis and empirical evidence. So we actually checked uh, several authentication protocols. In this case, we checked PAP, CHAP, and Kerberos. PAP stands for Password Authentication Protocol, and as CHAP, which stands for Challenge Handshake Authentication Protocol. Both of them require a username password combination to log in. PAP is not secure at all. It's been cracked before. CHAP, the same thing. It has a three-way handshake in the sense that it it challenges the user. The user sends a response to the server, which is not, it's sent in MD5 as an MD5 hash, which is crackable and also not secure. So that's why we didn't go with that. And finally, Kerberos, which is a network authentication protocol which has been cracked before, has some vulnerabilities that can be found. So we did not implement this protocol. We checked two-factor authentication, but at the same time, it's strong security, but it's not easy for the user, since they has to remember the password and then do biometrics, do something you have, something you are, whatever. And we wanted to find strong security with with easy usability. So we came up with we found FIDO. This authentication protocol uses has three important components. In this case, the reliant party application, which is the server requesting any request for online access to a resource. So that reliant party application connects to the RP server when trying to log in. So then the RP application connects to the FIDO client, and just to have this in mind, this is in the IoT device. So it will be implemented in the IoT device. There is a FIDO server connected remotely, and that FIDO server has a RP server which connects to the RP application and the IoT device. So the FIDO client in the IoT device has an authenticator, connects to authenticator, which can be embedded into the system, or it can be a third-party application like Google Authenticator. So the good thing about this is that the public key is stored in the FIDO server, the remote one. So if hackers decide to go for it, to attack it, they won't find the private key. The private key, it's only produced by the authenticator, which is not, which cannot be gotten unless you have, the account or the Google or the authenticator itself. So the private key is produced only by the authenticator. So by doing this research, we found that FIDO was the most secure and user-friendly authentication protocol because of what we mentioned before, and we actually argued that potential production IoT device companies should implement this password authentication method to help IoT devices become very secure, and avoiding the hacking by background account or by default password attacks, so they cannot connect remotely and steal personal information that's really important for the customers or users. So this is a graph that shows how two-factor authentication, multi-factor authentication has strong security, but it's difficult to use. CHAP, Kerberos, and other authentication protocols are easy to use, but there's weak security. And FIDO has both of them. And finally, so how we want to implement this, or what future work can we do after this? it's maybe actually implementing this protocol and IoT devices, such as actually a baby monitor or another IoT devices, to test its usability directly and if its security. So that's something that can be done for future research. And that will be the end of the slide. So thank you so much for your time, and thank you for listening to my presentation.